Okay, so I think we are all set. So let's look at what 3-2 has in store for us. All right. Where's my gray marker? Ooh, let's use brown. Okay, so 3-2 is all about parallel line properties. Oops. Let's fix that. There we go. Parallel line properties. So if you recall from yesterday, we learned how to name all of our angle pairs that we had. So we have our list over there, vertical corresponding, alternate interior, alternate exterior, blah, blah, blah. Now, those pairs exist whether the two lines that the transversal crosses over is parallel or not. It doesn't matter. We didn't say anything yesterday that the lines had to be parallel. We just drew two lines, crossed them over, and then I had all these angle pairs that popped up. Okay, if you remember from last night's homework, that first section, what was that, the 12 to 17? Those were not parallel in there. You had lots that weren't. So it doesn't matter if the lines are parallel or not, the relationship is still there. However, if a transversal crosses over parallel lines, oh boy, let's find out what happens. Okay, so this is kind of a big deal. So we'll put a big star. If a transversal crosses over parallel lines, the following angles will be congruent. We're going to make a list. Okay, so I'm going to draw a picture. So if I know that these lines are parallel, right? So let me give them some names. So let's say that's line A, line B, and I've marked them as parallel. And now I have transversal T over here. And again, I'm going to number my sets of angles here so we can talk about them more easily. 1, 2, 3, 4, 5, 6, 7, 8. So if you're numbering it the same way that I am, or if you're drawing the diagram as well, make sure that you number it the same way that I did. Otherwise, our examples won't make any sense. Okay, so our first set of angle pairs that are going to be the same, if I know that the lines are parallel, it's going to be our corresponding angles. So now what I can say is if I know the measure of angle 1, let's just say I know it's 100 degrees. Now I also know that angle 5 is 100 degrees because they are corresponding angles. That's so cool. So actually, I'm going to mark that. Let's say I happen to know that measured it and it turns out 1 is 100. That means angle 5 is also 100. claim that there are other angles in this diagram that you know are 100. Aiden, how do you know that?
That's a vertical angle.
Yes, we already know that vertical angles will always be congruent to each other, right? So that means 4 is also going to be 100 because 1 is. Same thing is happening with 8. That's also going to be 100. So now I dare say that there are a few more pairs that are already, who is marked congruent in this list besides the corresponding angles and the vertical? What other pairs in that list over there? Yeah.
Angles 2 and 3, 6 and 7 are congruent.
You're right. You're answering my next question. I want to know out of that list, so all the ones that I have marked as 100, what else are they besides vertical and corresponding angles in that list over there? Sam?
Alternate exteriors.
Yeah, I have alternate exteriors. There's a pair of alternate exteriors, 1 and 8, that are in fact the same as each other, aren't they? And Aiden just told us that 2, 3, 6, and 7 are all going to be the same. So I'm going to have another set. Well, we might as well do that one. What would their measure be? Yes. And how do you know it's 80? Yeah, you have, look at angles just 1 and 2. Don't they make a straight line together? They make 180 together. So if that one's 100, this one has to be 80. That has nothing to do with parallel lines. That's just, hey, I have a line. They always add up to be 180. But now I get to bring in, oh, hold on, I got vertical angles. So if that's 80, you're 80. And then I can also say, all right, well, I know corresponding angles are the same. Or I could say if that's 100, that means this one's got to be 80 as well. Oh my gosh. So if you take a look, both of my sets of alternate exteriors are congruent. What about the alternate interiors? They are also congruent. So if I know for a fact that the lines that are getting crossed by the transversal are parallel, that means not only will corresponding angles be congruent, but so will alternate interiors and alternate exterior angles. I'm going to add vertical angles, even though vertical angles are always congruent. It doesn't matter if they're parallel or not. So I'll actually, oh, well, I'm with you. We should. Whoa, oh my. That's a oh.
Yeah, we
I want to keep the highway as hard as the Montgomery. I can keep that.
Okay, so vertical angles, I mean, they're always congruent. It has nothing to do with the lines being parallel or not, but now we have everybody in our list that's always going to be congruent. Again, I can't stress this enough. You have to know that the lines are parallel though. If you don't know, you can't go around saying that none of this would hold true. They would still be corresponding angles. They'd still be alternate interior, alternate exterior. Look up here. I didn't mark any of those lines parallel, right? I didn't mark any of them parallel. And you still gave me all the relationship pairs. The pairs still exist. It's just if the lines are parallel, now you're going to get congruent angles. Okay, now what's up with the same side interior and same side exterior? They're not equal. Let's just look at same side interior. So same side interior would be like 3 and 5, for example. They are certainly not equal to each other. I have one that's 80 and one that's 100. What could I say, Carson?
That they are supplementary.
They are. Do you think that's always going to be the case, or did we just get lucky this one time that it was 180? It just happens to add up to be 180. Person?
I think that they will always.
I agree with you, because if you check this out real quick, you don't have to draw this one if you don't want to, but if I do the same thing where I know the lines are parallel, right? And let's just say that I just call this X. What's this angle right here? If that's X. 180 minus X. And then I can play the same game. Vertical angles are the same. Corresponding angles, since I marked them, oh, let me kind of finish. I have them marked as parallel, so my corresponding angles will match. So corresponding here, 180 minus x, corresponding here. So we can see, even if I don't use numbers, if I just use variables, it still holds true. If you take a look at your same side interiors, 180 minus x plus x, isn't that still 180? So that will always be true. Okay, so we do have some pairs of angles that are going to be supplementary. So
Wouldn't that stand true for also same side exterior?
you got it. Those are, and it's so nice because it all is, look at your alliteration there. Same sides, either interior or exterior, are supplementary. So easy to remember. All right, so if the lines are parallel, I'm going to keep saying this over and over and over again, the lines being parallel part, because it's crucial. The following are supplementary. I wonder if this is being picked up on the video, or the just, it's thundering and lightning for anyone watching in internet land. Okay, so our supplementary angles are going to be our same side interior and same side exterior. If you wanted to add a linear pair here, same thing. Linear pairs are going to be supplementary no matter what. It doesn't matter if the lines are parallel or not. That's just always, you know, something that's true about a linear pair. So if I were talking about two angles right next to each other, or back up in this example, if we had like 7 and 8, for example, if they form a linear pair, which hopefully, remember, linear pair has to be adjacent to each other and supplementary. That's what makes a linear pair a linear pair. They're always supplementary. Again, that actually has nothing to do with the parallel lines, but if you just want to have it in your list, I'll put it in parentheses also, kind of up to you. Linear pairs are always supplementary. Regardless of parallel lines or not. Okay, we have one more theorem about this, and then we're going to see how you could use these concepts in a proof. What? Mrs. Xavier, you mean to tell me that we get to take this and now apply it to our proof practice? Yes, I know. Does the fun ever end? No, no. All right. Gotta flip. And we have our one more theorem here, and then we'll see if we can do a proof together maybe. So this states, in a plane, if a line is perpendicular to one of two parallel lines, then let's see if we can figure out how this sentence ends. I'm going to give you a minute to jot this down, and then we'll see if we can figure this out. All right, let's see if we can figure out how to finish this sentence. All right, I'm gonna draw you a picture demonstrating this. So let's assume that the plane is my paper, okay? So I'm on the plane represented by my paper. If a line is perpendicular to one of two parallel lines. So here's what I know. I'm gonna start off with some parallel lines. I'm gonna mark them as parallel, so I know that they are. Okay, cool. And now I have a line that's gonna be perpendicular to one of those two. So let's draw this line. And let's say I know for a fact, let's give these some lines and names, A, B, C. I know for a fact that line A is perpendicular to line B. Can you make a conclusion about how A is related to C? Person,
It's also perpendicular,
how do you know?
because when, something is parallel, it means. So, well, when you have one that's perpendicular, and it's one parallel line, that means the both.
Let's say I call that angle 1 up there and here's angle 2. Aren't those corresponding angles? And we just learned that if the lines are parallel, which I know that they are, corresponding angles are going to be the same. So if that one's 90, I get to conclude that this one is also 90. And once I show that I have 90-degree angles, then yeah, I have a pair of lines that are perpendicular to each other. So to finish off this sentence, we're going to say, in a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the second line. All right, so let me see, sorry, I'm cutting off your view. Let me see if I have a, I think there's a proof that I like to do in here. Let's do. All right, we'll start off with a nice, easy one. I'm going to draw it right in the notes, so we have it there. Okay, so here's how this one goes. All right, so let's draw this picture. You're going to have two parallel lines. We're going to label the top one K and the bottom one L. And then I'm going to have a transversal T. All right, so in the given, I will tell you that lines K and L are parallel. Oh, and we have some angles. Let me number them. 1, 3, and 2. Just like that. Okay, it's parallel to L. All right, they give you the transversal T cuts K and L. That you usually don't even see that. We don't even, I'm not going to bother with that. All right, we need to prove that angle 1 is congruent to angle 2. Oh, but we already know that because they're corresponding. That one's silly. You know what I'm going to do instead? Let's do, let's prove angles. I'm changing what the book has because, I mean, it could be done in one step. So I'm going to do something harder than that. Let's show that angles 1 and 4 are supplementary. Oh, that's a good one. Let's do that. Prove angle 1 and angle 4 are supplementary. So A few things when we're doing these parallel line proofs. Let's say I wanted to talk about this angle, but it doesn't have a number on it. You can add a number there if you want to. So just because it's not given a number in the diagram, it doesn't mean anything. You can still use it. I guess it kind of means, hey, there's probably a way to do this without that angle, but it's not wrong to use an angle that's not numbered. So if there's ever an angle that you want to use, so if it's on like a proof quiz and it's like actually a diagram that you can draw on, you can literally add an angle, add a number if you want. So in fact, I'm just gonna number all of them. Why not? 5, 6, 7, 8. I was copying the book at first, so that's why I didn't go in order. Sorry. So you can always use whatever angles you want to, numbered or not numbered. You can add a number to a diagram, no problem. The other thing that I want to mention about proof quizzes specifically, if you need more steps than there are lines in the box, you can have as many steps as you want. And you also, sometimes kids feel like they have to fill every box. No, you don't. It's just, hey, here's some space for you to do your work. You might use less, you might use more, it doesn't matter. Don't feel like you have to have something on every line. You don't. Okay? Okay. So let's see if we can use what we just learned and put this all together. All right, cool. So I want to show that 1 and 4 are supplementary. Unfortunately, 1 and 4 don't have a match over there, do they? They are not vertical corresponding, same side interior, same side exterior, alternate exterior. Otherwise, it would be a one-step proof and I'd be done. However, I could say something else. Well, first I got to start with my given. Statements, reasons. 1, I have K is parallel to L, given. All right, got that. 2. 1 and 4 don't have any relationship to each other. Julia. You're yes, you can say that. I think you said, what's the relationship between 1 and 8? Yes, same side. So there's so many ways that you could go about this one, and hers is perfectly fine. She's saying, hey, well, you know 1 and 8 are supplementary because they're same side exteriors, right? And then don't we know that 4 and 8 are the same because they're vertical? Right? Are you with me? So I could definitely go that route. You could have also said, oh, well, look, 1 and 2 are corresponding, so they're the same. And then you could have said 4 and 2 are supplementary because they're a linear pair. You have so many options here, but let's go ahead with what Julia laid out for us. So she said angle 1 and angle 8 are supplementary. Oh, and has a D in it. There we go. So now the question is, how do you show that as a reason? Okay. And there's a whole phrase that you would write, but we've sort of condensed it into a series of symbols. Okay, you ready for this? So here's how I'm going to write it. I know for a fact that I have parallel lines. That was given to me. If I didn't have that, I couldn't do any of this. But here's what we write. Parallel lines. And then I'm going to use a double arrow like this with 2 lines. That symbol right there stands for parallel lines give me, or parallel lines produce, yields. That's kind of what that symbol is. It's like, hey, you know this information and that information now gives you. So one of the things that we can say is that if I know I have parallel lines, I have all those pairs of angles that are going to be supplementary, right? We wrote them out on the last page. So you can write parallel lines give me same side exterior angles supplementary. I know it's kind of a lot to write, but you will get the hang of it, I promise. So whatever the parallel lines are giving me, so if I were using the corresponding angles, instead I would have written corresponding angles are congruent. If it was alternate interior angles, I would have said alternate interior angles are congruent. But here I have same side exteriors and they are supplementary. And now, I believe she said, hey, well, 4 and 8 are the same, because they're just, what's 4 and 8 to each other? You got it. So angle 4 is equal to angle 8, because they are vertical. And now all I have to do is swap out angle 8 for angle 4. And then I get what I was trying to prove. I want to prove that 1 and 4 are supplementary, and I can say it now. What's our reason? What did I do? I did substitution. I swapped out the 4 for the 8. For the 8 for the 4, whatever. Substitution. Ta-da! Oh my gosh. These don't seem so bad. They're not. They're not. This is weird, but you'll get that because you'll do it so much, it'll just become second nature. Should we, let me see if I can find one more real quick. Those ones are so, I mean, that's about as hard as it's gonna get in this section. Oh, maybe not. Oh, yeah, okay, we could do one more. I have a thought. I don't see one in the book like this, but it's okay. I can make one up. Let's say, let me give all the lines their names, A, B, C, D. And let's say in the given, I got to number a bunch of angles. Let's say I wanted to prove that 1 and 16 were the same if I knew A and B are parallel and C and D are parallel. Prove angle 1 congruent to angle 16. Yes, we can totally do this. And not even in that many steps. Want to try it by yourself? Try it. I'll give you a minute or two. See if you can make heads or tails of this. Knowing what we just learned. Okay. I assume you all have step 1. Is that fair? A is parallel to B and C is parallel to D. Okay, so I assume that you have the given. All right, Aiden, where'd you go from there?
So should I just say my whole process?
Sure.
So from that, I did corresponding angles of angle 1 and angle 9.
Yes, okay.
Then I did alternate exterior angles of angle 9 and angle 16. and then you can substitute angle 1 for angle
Sounds perfect.
9. I don't know that these things.
Okay, let's work through that together. But does that seem plausible? And you didn't have to go that route. You could have said, you could have done the same thing, but kind of jumped over here. You could have said 1 and 5 are corresponding, and then 5 and 16 are same side exterior. So you could have used this set of angles instead of this set. Doesn't matter. You also didn't have to use corresponding. You could have done, I don't know, maybe you do, this would be weird, but you could do it. 1 and 11 are supplementary because they're same side exteriors. 11 and 6 are also supplementary. And I don't know if you remember this from last week, but if you have 2 angles that are supplementary to the same angle, what does that mean they are to each other? Equal. Yeah, that was the congruent supplements theorem. So you could have gone that route. There's like, probably you could come up with 15 different ways to do just this one proof. So I like where Aiden went, so I'm going to write that one down. So he started with angle 1 being congruent to angle 9. And the reason that you're going to say for that, what are they to each other? What's their relationship? They're corresponding. And didn't we just have that list? Hey, if the lines are parallel, these are the lines that are the angles that are going to be corresponding, right? Anytime you have that, this is what you're going to say. Parallel lines have given me congruent corresponding angles. That's how we write that. So I know I have parallel lines, right? They gave it to me. The parallel lines are telling me, and then any one of those 5 things that we learned. So we had 3 sets that were congruent, corresponding alternate interior, alternate exterior, or I have 2 sets that are supplementary, same side interior, same side exterior. All of that came from knowing that I have parallel lines. And that's how we write it. Okay, cool. So now I know 1 and 9 are the same. Now I could say 9 and 16 are the same, can't I? Angle 9 has to be the same as 16 because what are they to each other? What's the name of their relationship, 9 and 16? Alternate exterior, yes. And isn't that another one that's in our list? Yes. So alternate exterior. So I have another set of parallel lines and they are giving me congruent alternate exteriors. Yes. And now I have 1 is equal to 9 and 9 is equal to 16. So can I just leave out the Minuteman and just say 1 is equal to 16? Minuteman, middleman is what I meant. Not a Minuteman. What are we in the American Revolution? Oh gosh, kind of. Anyway, what's my reason right there? Yes. If you said transitive, that's fine. Substitution. And that is what I wanted to prove. Oh my gosh, are they that bad? Not that bad, right?
I mean, I can see that route and I did it in 6 steps, but
You totally can. I bet there's so many different ways that you could have gone about this. You could have said angle 1 is congruent to angle 4 because they're vertical. And then 4 is the same as 12 because they're corresponding. And then 12 is the same as 16 because they're corresponding. So many options. Oh gosh, love geometry. Okay, so let me give you your homework. You may have noticed, or maybe you forgot, but you were supposed to have a quiz tomorrow on 3-1 to 3-3. How can we possibly do that when we haven't done 3-3 yet? So obviously your quiz will not be tomorrow. So it'll probably be Thursday, obviously. It's not tomorrow. So tomorrow we will cover 3-3, but let's look at the homework for this evening. I would love for you to do the following. Page 81, numbers 13 to 16. And then also on page 82, I'm actually going to take one away from what I was going to ask you. So we're just going to do 18, 19, 21, and then 24, 25. Okay, And that is it. So you guys got a good 15 minutes to get started. Let me know if you have any questions at all. We'll stop this video. Yeah, sure. Just make sure you sign up, please. You might have to flip the page over if that's full.